All right, I think now hopefully it should be fixed. It should say Unit 1 office hours. I don't know why, but I guess we got to go with it, right? We got to continue on. Confusingly says Unit 2. I don't know what the deal is there. All right, hope everyone is doing fine. I see Joseph is here. I see Paulo is here. I see Lyndon Smith is here. So welcome to office hours. Let's go and craft our agenda. And on there is continue with our project. Continue with our project. We're going to continue with our project. What else we want to? Someone was asking me a question about the true mean, the calculation of the true mean calculation. So I put that on the agenda. Someone was asking about object-oriented programming with respect to plotting, and I will mention that as well. Talk about that perhaps today. All right, I see that someone is asking is I would like to print a part of my dictionary, like let's say the first four elements. So the problem with there is that there really is no order when it comes to dictionaries, right? There really is no order when it comes to dictionaries. So there really is no guarantee about what the order is. So you cannot slice a dictionary. Just like you would slice a list, you cannot slice a dictionary in Python. And the whole fundamental thing is that while, yes, there is some sort of internal order in a dictionary, for example, you can iterate through the keys, dictionaries don't rely on position and order because the way you index values is via a key. So when you say print the first four elements of X, where I assume here the variable X is a dictionary, well, you really can't. However, there are things you could do. Let's go in office hours here, open up a new notebook. All right, so let's say I have my dictionary. I could say for what I could do is the thing, if I say for key in my dict, remember if I iterate through a dictionary, I iterate through the keys. So I print out the keys, I get A, B, and C. And notice there was an order there. It was the order of creation. And this could very much change, right? If I have it something else, the order change. So there is some sort of order in which you print it out, but you cannot do something like this because unhashable types slice. You cannot slice a dictionary. We have to give it the key. One thing you could do is there is from collections import order dictionary. There is a class called order dictionary, and I have rarely used it. I rarely use it. But let's take a look at the documentation. So dictionaries remember the insertion order. In other words, it keeps track of how things were inserted, the order in which their insertion. Newer versions of Python, the standard dictionary implementation does that, but that's sort of we luck out. We really should use, if we really want to keep track of keys, the order in which we add keys into a dictionary, we should use an order dict. So here I created my empty order dictionary, so I can say my dict, and I can create those key value pairs. Now, if I look at the methods available for this dictionary, let's see if I have get, I have items. So then what I could do is I can say for I key in my dict, and I can say, right, if I is less than 4, then I can say print out key and print out my dict and key, something like that. And I forgot to use enumerate. I could do something like that. That's the way I would do it. If I want my dictionary to have some sort of memory of insertion order, the order in which I inserted keys and values, I use an order dict. And then I would iterate through and check, well, is my iteration variable less than 4? If it is, then do whatever I wanted to do. Right? Maybe I want to store those values in a list, right? I can do something like their list comprehension, right? And oh, there you go. 1, 2, 3, 4. I could do something like that as well. Okay, so looks like there are 2 streams going on, and I have 2 different chats, annoyingly. So I see Tom, I see Esther, I see Naya. Make sure you access. I'm going to send you a link. People on the other chat, go there. Looks like they didn't copy the whole thing. Try that once more. And for some reason, 2 streams are going on at the same time. One has a different link. One has a different link than what we're used to. So please, please visit that link. So I only can keep track of one chat. All right. Let me know, Joseph, if that okay, looks like thanks. I'll take that as I've answered your question. So I answered that. So the agendas continue on with our project. Someone asked about the true mean calculation. I can talk about that. And perhaps we'll look at some object-oriented programming with respect to plotting. Let's go and segue into, let's go back to our project. Right, where do we put that? I think we put that in data wrangling. And maybe not. Where do we put that? Was it in office hours? It was in mini projects. We put this file here. So we put this file, and we had our functions. So hopefully this is more readable code, right? Hopefully now that we've organized it, we can just look at what's in here and understand what's going on. And we're flagging practices that have a z-score greater than some cutoff. And we talked about how we want to get familiar with Git. Get familiar with Git tools. Version control with Git. So now what we are going to go ahead and do is we're going to go ahead and I'm going to copy this file. I'm going to go ahead and move it elsewhere. I'm going to move it into the main directory. So if I go to data course, there is my file right there. And what I'll do is I'll create a new directory, a new folder where to put that file. I'm going to put that file there. I'm going to rename this. I'm going to call this drug. I'll call this prescription drug analysis. I'm going to move this file into that directory. So I'll click on that and I'll move into, well, the annoying thing is, let's just do this in the command line. We talked about, let's see how we can do that in the command line. All right, let's practice command line tools. And I'm going to go ahead and type ls to see where we are. So I see the data course. So I'm going to change my directory into data course, cd data course. using tab autocomplete to speed things up. And then I can say type in ls to see what I've got. Okay, there is the drug data analysis file. If I want to move that file into a directory, the way I do that in the command line is say mv, which stands for move this file to this target. I hit enter, and now I got to change my directory into where I moved it. CD stands for change directory, prescription drug analysis. I hit enter, and now let me type in ls, which lists the contents of where I'm at, and sure enough, I see that file. Right. I thought that was a lot easier than just dealing with this, dealing with moving it here, which is not very user-friendly in my opinion. So we move the file, and I see a lot of output here in my terminal. It gets a bit crowded, so I'm going to do Control L. Control L just clears the screen, right? Brings it to the top, a lot clearer where I'm working with. Any questions so far what I've done here? Well, my next step I'm going to do is going to initialize a Git repo. That's my next step. All right. So the next step, I got to create a Git repo. In other words, I got to tell Git, which is a program that does version control, one program that does version control. I got to tell it that this directory here is a repository. In other words, a place where we're going to put the code for our project. And the way we initialize a directory to be a repository, in other words, to have this program Git to keep track of things, is we say git init. So we say initialize empty Git repo, prescription drug analysis. So now this here is being tracked. Git is a version control software. It's not the only one. It's the most popular. I'm not sure why it's the most popular, but there's other ones called, there's one called Mercurial, and there's one called SVN. There's Mercurial. I misspelled that. Mercurial. Version control, and there's also SVN, Apache Subversion. There are other programs to do version control. The most popular one, I don't know why exactly, is Git. So that's what we're learning today, Git. But but luckily the concepts utilized for Git can be translated to other version control softwares. All right, so I want to know what the status. So I'm going to do Git status. Sometimes the terminal freezes on Jupyter Hub, so just refresh the page. Git status. I hit Git status and I see a couple of things. I see a couple of important messages. I say there, tell me on a branch called master. We'll talk about what that means a bit later, but we're on a branch called master. There's no commits yet. Okay, we'll talk about what that is. Untracked files. Here is a list of files Git isn't tracking just yet. So there can be files in this repository, but Git isn't tracking all the files. We have to tell Git what files to track. And what does it mean to track a file? What it means to track a file is basically that Git has an eye on that file, and it will tell you if it has changed, and it will tell you the changes of that file. Remember how we're at this whole idea of having a history, be able to easily understand what were the changes and when they occurred, and perhaps even who made those changes. So by default, Git's not going to track any files. You have to tell it which files to track. So with that said, let's go ahead and track that file. In fact, it even tells us how to do that. Git add. So git add drug data analysis. Now it's tracked. Let's hit Git status to see what happens. And I see a couple things. I see no commits yet, but changes to be committed. I see a message telling me the changes that should be committed. So what does that mean exactly? Well, what this means is that the way that Git works is that we move, you can think of figuratively what is happening, is for Git, we have a set of changes. These here are my set of changes. And just draw mesh shapes. And what I do is I move these changes to what's called the staging area. So I'll move these to the staging area. And once these changes on the staging area, then they are ready to be committed to history. Then they're ready to be committed to history, added to this log, this book, this entry book that keeps track of what is going on in our code base. So let's try that out. We've added that file to the staging area. It's ready to be committed. So we got to commit this change. In other words, you can think of it as making it, writing it down in history. So we say git commit -m. The way the command line works, program is the command line, is options of a program are manifest as a dash letter or dash word. So we're running the git program, we're running the commit command, and we're using the option M, and this here stands for message. We are going to write a message for that commit. What is the message that goes into the entry book? What goes into our entry book? And these commit messages, could really be anything really, but should be readable, right? Should be something that makes sense. It should be a summary of what occurred. And typically, there's a strong convention in version control is that our commit messages use present tense. And you can think of the commit message as following the phrase that follows this sentence. With this commit, blank. With this commit, what happens? With this commit, we're going to add drug data analysis file. So that's what I'm choosing as my commit message. It can be whatever I want, but there's a strong convention that we use present tense, and you can view the commit message as what follows the phrase, with this commit, we will add the drug data analysis Python file. I'm going to hit enter. I get a little messed up. And the reason why is because when we look at the logbook, it's going to tell us who made the commit message. It's going to tell us who made the change. So let's go ahead and run this. It even tells us, even helps us out, telling us what we need to run. So let's try that out. I'll say git config global. It wants my my email address. And I'm gonna give a fake email address. This is just for practice, so I can just say don@don.com. Something silly like that. Git config, and it wants to know my username. I mean my name. So I say global user.name Don. And this only is going to happen initially. This is only going to happen once for our pod because we haven't run git just yet. So this is the global configuration. So now I'm ready to go. In the command line, if I want to go back to previous histories, previous things I've done without typing things, I just press the up button. So I can cycle through what I've had. This is great because maybe you made a mistake, you had to do something else, and then when you go back to run that line, you can use the history to figure out, get back to what you wrote. And that's what I do there. That's what I did there. Now I've hit enter. And notice it gives me a little message saying, hey, what happened? Well, I've added one change, and that had 52 lines. So now, let me do Control L, git status, nothing to commit. What this means is that now that I've committed the change, there is no other changes to commit to history. It's sort of up to date. So git status, nothing to commit. Type in git log, and notice what I have when I type in git log. This is the log book. It is telling me I'm in a branch called master. We'll talk about what that is when we go with multiple branches. We see this commit message right here. Right, the author, the date, and the commit message. So now you can imagine as this gets longer, this code base evolves, we can access the logbook and check to see what has happened in the project. And here we see there's one commit, and we know what it did because they put a very readable message. Add drug data analysis. Any questions before we make more changes to our file? All right, I'll take that as no questions. Now let's go back to our code. Let's go back to our code. And in fact, let's go ahead and improve on it. So notice that this code will not run again, right? Let's try that out. Let's see what happens if I try to run my code. I say Python, and I say drug analysis, and I hit py, and I get errors. I get error messages. And here, if I look at the error message, I say file not found. No such file. DW dash data in the script. What do you think is going on there? Why do I have an error? What do you think is going on there? Why is it not working again? Well, the reason why is because this file, when we run this script, notice there's no directory, dw-data, and the file, because we've moved the location of the file. So these locations, right, these locations are relative to where the file exists. And that doesn't appear to be the case anymore because right now the data isn't in this directory. So we could do two things. One thing we could do is we can go ahead and move the data to this directory, or we can fix the location. I think it's best that we fix location, so I will say the location of the file is data/home, tilde is my home, data course, data wrangling. That should be it right there. Let's see, other ones I need to fix, right? Fix that one right there and fix that one. Hit save. And now my mouse has died, which is annoying. Let's run that again. Get a file not found error. And all right, there's probably one other one I didn't solve it. Looks like it's saying that is occurring in line 55 right there. line 6. Did I forget to hit save? May have forgotten to hit save. Let's try that again. Oh, I know why. Because this file is no longer, I'm opening up the wrong file. Let me close this there. All right, there we go. Then let me run that again. Still get an error. And let's see what could be going wrong. Ah, because it's in mini projects. Right. Still have that path wrong. Data course, data wrangling, mini projects. There we go. Mini projects. Save that. Let's go back here. Let's try that one more time. And I still get an error. Let's see. Data course, data wrangling, data DW. Ah, I have it flipped. Many projects. There we go. All right, that should work out. All right, no error message. Now let's do get status. Notice I've updated my model, updated my code. So if I look at get status, let's see what it says. All right, so if I say get status, I say, hey, this file that I've modified, this file here has been modified. So notice now, since Git is tracking this file, it knows that that file has been modified. Because what it's doing, it's looking what currently is in my computer, the current state of the file. It's looking at what the file should look like based upon what I've committed to history. It says, it looks at them and says, oh, there's a change. What you currently have is different what is based upon history. So Git says, hey, this file has been modified. So now if I say git diff shows me the difference. So Git is able to tell you what exactly of the file has been modified. And notice it says, hey, this line was modified to this. This line was removed, that minus, and this is what it has in its place. So not only does Git keep track of if the file has been modified, it also tells you what is a modification. This is great because I'm not sure about you, if you've ever been in a situation where you modify a file and you're like, wait, what did I modify? Did I modify that? Did I, that second guessing is not involved here anymore. I can say git status, git diff to show me the difference. Now, what if I want to commit those changes? I want to commit those changes to history. Well, let's do, what I'm going to do is I've got to add that change to the staging area. So the way to add that change, I say git add the name of the file, which I call drug data analysis. I'm going to do git add once again, but here it's going to add those changes. So git add drug data analysis. And now those changes are in the staging area. What comes next is committing those changes. So git status. All right, changes to be committed. So then what I do next is I say git commit -m, and let's choose a good commit message, right? Because if I choose something that's not readable, is not really explain what the commit does, then I'm not helping my future self, right? At the very least, let's help our future self. So git commit -m, and I'm going to say fix data fix CSV data paths when reading. Right, it's just a very short title. In fact, you can write a longer description, but here you can think of this as sort of a title. Fix the CSV data paths when reading. Hit enter. And now I've committed the change, so I do git status, nothing to commit. Everything is clean to go. Git log. There are my 2 commit messages. All right, so now you can think of what I have here is and my mouse died, so I'm using my trackpad. So we have 2 points in history, 2 commits. Very simple code base. Now let me know if there are any questions before we improve on our file, add some new things, and let's go ahead and keep on using Git. All right, I'll take that as things are good to go. Now, all right, so let's go back to our file. And notice it does the analysis, but it doesn't really do anything with the results, right? It just does calculate the results, but doesn't do anything with it. Any suggestions on what we should do with the results? Any suggestions on what we should do with the results we get from our analysis? What we should really be doing? Yeah, plot them or write them to some file, right? That's what we're missing here, right? We do the analysis, but it'd be nice if we take this, which is, remember, this here is a pandas data frame. It'd be very nice if we take this and we dump it to disk. We create a CSV file of the practices that we have flagged. So let's do that. Let's go ahead and do that. So it makes sense we define a new function. So we'll do that right here. Define def. I'm going to call this dump data. I don't know, something like that. Dump data. It's going to accept the results, which I assume is a data frame. Here I write my doc string. It says dump pandas data frame of the results to disk. So I can say results to CSV, index false. By default it has the index, and perhaps I just don't want that. So here I have the file, and I say flagged, I say practices flagged.csv. Then I say call dump data anomalous practices. Save that file. Let's go back to the terminal. Let's run that. Let's run our file again. Let's see if it works. I got a name error because I have a silly typo. Let's fix that. Let's go here. Let's run it. All right, that ran. Let's type in ls. And here is my CSV file. Practices flagged. You call head on practices flag. And there we go. We have little information about the practices we flagged. We have the name, the address, the z-score, and the raw count. So some of these here are rather low, right? They only had 2 prescriptions. So maybe we don't really want to have them in our results. So let's go back here to our file, and we're going to say, we're going to give a criteria. We have a z-score cutoff, and we can define a raw count cutoff as well. Raw count cutoff. Say 50 by default. Then here we just update our script. Raw count cutoff. And we can say something like unique practices, and we can say query. Say query, we say count has to be greater than raw count cutoff. Here, I'll just break this down into, oh, I have it there. I have a second query, so maybe I should just copy that and paste it right there. Okay. And of course, I'll update my doc string. Return practices that have a z-score greater than the cutoff, and count greater than the cutoff. Z-score and count greater than the cutoff. Be a little more succinct there in my language. Okay. So I made the changes to my file. I'll hit save. And if I go back here, let me just run the script again. Practices flag. And yeah, it looks like I've removed those records in which they had a very small raw count. All right. Now, I made those changes, but if I do get status, notice that they say modified, the file has been modified, right? I make the changes, but I got to commit those changes. But one of the things that I'm going to do, and it's sort of good practice, is that let's go ahead and create a separate branch. Now my mouse has died, so I'm going to draw very poorly, more poorly than usual. As you can think, here's our history. And here's our history of our master branch. And what the typical workflow to do is we branch off. We have a branch off point in history where we make changes, we commit changes. And then once we're ready, we can merge those changes into master. And this is great because other people can be working on the project and different aspects of the code base, different aspects of the repo. And everyone will create their separate branch, make their changes. Oftentimes, testing is involved in the master branch. In your test branch. Testing's a whole other discussion. We can talk about testing perhaps in some other time. we can write up basically tests that are run to make sure that the changes you're making to the code base work. Not going to break things. So good practice is that we branch off and then we make the changes. Unfortunately, I forgot to branch off before we make the changes, but that's perfectly fine now because I yet to commit those changes. So let's branch off. So I'm going to say git checkout -b and the name of the branch. I'm going to go ahead and call this script improvements. I'll call this branch script improvements. So now I hit enter. Now if I do git status, notice it says I am no longer on branch master. I am on script improvements. And let's do git diff, and here are all my changes to my file. All right, so it looks like let's go back here to my file. Okay, let's make that last change. Nothing, just aesthetic reasons. All right, git diff. So notice it has the changes we made. But notice the changes to these files they're really two discrete. There are two main changes, right? There are two main changes we made to this file. We allowed it. We have now dumping the results to disk. You can think of all those changes related to that is one concept, one idea. And there's the other idea of adding this feature of doing a cutoff based upon raw count. So you might say, well, we can do git add, and we can say the file drug data analysis, and then we can say git commit and say something like dump dump results to disk and cut off based on raw count. We can have our commit message signifying the main differences we add to our code base. That we're cutting off, we're dumping the results to disk, and we're cutting off based upon raw count. Now, before I hit enter, my question to you is it good that I have these two changes that are unrelated be part of the same commit, the same log entry in my history? What are your thoughts? All right, let's think about it before we hit enter. Let's look before we leap. Is this good practice? Having one commit message that really refer to multiple changes. Exactly. No, because first of all, in our history we have these two changes that are brought together, and this is bad because, well, why not just separate them? There's two different changes, so we'll have them as two separate commits. But the other reason is the nice thing about Git and any kind of version control software is it allows us to kind of roll back and go back to an earlier project state. And these commits represent discrete changes in our code base. So if they're lumped together, then if we were to go back, we were to undo that change, they travel together. They're one unit, however, they represent two different ideas, two different changes. So in fact, we will separate them out. So let's go ahead and talk about how we can go ahead and have two separate commits on a single file. Let me hit refresh here because these terminal always freezes, which is really annoying. Let's see. I don't know what's going on here. I don't know what's going on. Looks like it's messed up. All right, there we go. All right. So now what I got to do is I got to reset my file. Reset head drug data analysis. That's going to take those changes and unstage them. I've unstaged my changes. In fact, the way I just basically read the message, right? To unstage those changes, right? There's a lot of little help messages here and there, which I should take advantage of. All right, so if I do git status and git diff, all right. So now I got to restage my changes. But notice I want to have two separate commit messages. So what I got to do is I do git add -p, the name of the file. What the -p option does, it's called patch. It allows you to commit parts of a single file. And this is great because I can have a separate commit for the two different discrete changes. Let's see what it says. So let's see. It gives me this change. And it says, do I want to stage this hunk? I don't know why it's called a hunk. But they were asking if we want to commit this, stage this hunk. This part of the change in the file. But notice in there, it has the changes kind of put together. It has a change with the cutoff and the change with the dumping the file to disk. So we're going to say S for split. And this will split the hunk. So now we're split into 3 hunks. So notice we have a change that adds the cutoff, adds a doc string for the cutoff. We want to stage that, right? We want to stage that. So I'm going to say, yes, stage this hunk. And here's the next hunk. And it says, notice the change for the cutoff is there along with the function. So we got to split this hunk. So we'll call S for split. And it says, sorry, cannot split this hunk. So unfortunately, it cannot split this hunk. I don't know why, but it's pretty annoying. It doesn't want to split this hunk here. I don't know why. It should be able to. Adding question mark. And what I can do, let's see if I have any options to do for this further, not stage this hunk or any other later hunks in the file. Select the hunk to go. And let's see. Manually edit the current hunk. And let's see. Say no. I'm going to say quit. I'm going to quit this. I'll quit this process here. I'm annoyed that Git, for some reason, cannot break the hunk even further. So let's try that again. And I will say no there. Split. I cannot split this hunk. So what I'm going to do is I'm going to do something that's kind of annoying. I'm going to cut that function right there. I'm going to cut it, go here, repeat the process, and let's see. Say split. Yes. Let's see if this splits. This is so annoying. I'm going to quit. I'm a little annoyed at Git for not doing what I wanted to do. So I just deleted that. Not great. All right, and I don't. Sorry about this, guys. All right, so I see the change here. So I say git add the file and git commit and say add cutoff, count cutoff for flagging practices. Now I've made the change. Now let's go back here and let's add the parts that I removed for the time being. Git diff, and there it is. There's the changes for let's see, we're going ahead and I'm wondering what is different with this line. Yeah, this would be a change for adding the file. So I'm going to say git add the name of the file. Let's commit that change. I'm going to say here is my commit message. Support dumping results to CSV to a CSV file. And now if I say git log, I have those two commit messages. All right. Sorry about that diversion. Okay. So now what I'm going to do is notice that these changes are on a branch called script improvements. So if I were to sketch out my history, how my history looks like, so I have two changes. This change here, those two commit messages, and then I branched off. And when I branched off, I had two changes. So here is my improvements branch, and here is my master branch. So if I go back to the command line, and I say, if I want to go back to the master branch, I say git checkout the name of the branch. Git checkout master. And now if I type in git log, notice my history only has two commits. And this makes sense because the master branch only has two commits. The new branch that I created has 4 commits. The changes are on the other branch. They're not right now on master. In fact, this is great because if I go back here to my file and I hit refresh, notice my file hey, wait a minute, it looks like what it was before. And it's not that it lost the changes, is that Git is a pretty cool program. What Git is doing is it is showing you what the file looks like on your master branch. It knows how it looks like on the other branch. So if we were to decide to go back to the other branch, Git will show us how the file looks like on the other branch. Notice we're not keeping track of different file names and whatnot. We can very easily say git checkout and I called improve script. Forgot what I called it. No problem. I can say git branch to show me all the branches. There it is. Git checkout. Git checkout script improvements. Git log. Those changes are there. Let's refresh our file. The changes are there. So now what I want to do, let's git checkout master. And let's merge in those changes on that other branch onto master. Let's try that out. So I git merge in the name of the branch. Script improvements. And now notice it has a little summary of what happened. One file was changed, 10 insertions, 4 lines deleted. Git log, notice what it says here. This commit is part of master and part of scripts improvements. So now my master branch has the change. And this is a typical workflow when you work with Git. You don't modify the master branch directly. What you do is you branch off, make your changes, and then merge back in. Merge it in back to master. All right. We're out of time, so we will definitely tomorrow take care of these other 2 points that I've neglected. Well, that's our agenda for tomorrow. Those do here. Talk a little more about Git, and then, yeah, talk a little more about Git. A couple of things we still need to learn about Git. We haven't talked about remotes. We haven't talked about rolling back changes. And then from there, we're also going to work with the argparse library in Python. Flesh this out a little more of a nicer script that we can work in the command line. All right, so with that said, we are out of time for today. So take care, guys, and see you later. See you tomorrow. Have a good